Hi everyone, this is Hossein from Vijay Academy, and today I'm here with Amir. How are you, Amir?
I'm good. How are you, Hussein?
I'm good, thank you. What's up? How's life?
Life is good.
All right. So I have an integration problem for you. Hopefully you enjoy it because you have to enjoy your life. Yeah. So
Yes.
so this problem, as you can see, it's
hmm
you need to evaluate this integral. So the integral is r. The expression inside the integral actually is r times e to the power of r divided by 2. So please go ahead and show us
Yeah.
how you solve this problem.
Yeah. Uh, if we just had e to the power of r over 2, that was very easy. But since we
Yeah.
have two kind of functions, one is
Mm-hmm.
r, I call them two functions. One is r and the other one is e to the power of r over 2.
Mm-hmm.
Uh, as a rule of thumb, in such circumstances, we can use integration by part,
Mm-hmm.
which I can write as aside here. So
One is a polynomial function, the other one is exponential.
yeah, and exponential is always easy,
Mm-hmm.
for differentiation or integration. It's always easy to take
Yeah.
integration by part. So when we have u times dv,
Mm-hmm.
uh, we can have u v minus v du,
Yeah, thanks for
correct?
the reminder. Yeah,
Yeah.
yeah, that's great.
So in this case, I'm gonna name r as u,
Mm-hmm.
and I'm gonna name e to the power of r over 2 dr as v.
Mm-hmm.
So for the first one,
Mm-hmm.
uh, I'm gonna take derivative. So it's going to be du equals dr. And for the second one, as we know, e to the power of x, the integration is, the integral of that is, again, e to the power of x plus constant. So here instead of x, we have r, dr. So the integration is in terms of r as the variable. So v
Right.
is 2 e r over 2. And we just skip c as constant here.
Right.
So if I call this integral I,
Mm-hmm.
therefore I is equal, so this was actually u and this was dv.
Mm-hmm.
So using this relation, we have u times v here,
Mm-hmm.
u here, and v is here. So it
Mm-hmm.
is 2 r e r over 2. So that's the first term of the relationship for the integration by part. And for the second one, we have minus integral of v times du. So it is 2 e r over 2. This is v times du, which is dr.
PR.
So we just need to solve. So we actually transformed this integral to this integral.
Right.
And the second the second term is a very simple integral to solve. So
yeah, basically what you did, you use integration by part to
yes,
reduce the degree of the polynomial function.
correct. Yeah, to get rid of one of
Mhm.
those multiplications here, which is r
Right.
here. So it is equal to 2r e over r over 2 minus 4 e r over 2
Mhm.
plus constant c. So
Mhm.
I just solved, you know, the second integral, the second
Can you
term.
just, yeah, I know what you did, but maybe some viewers couldn't follow what you did for that, the second term, that integral. Can you just explain a little bit how you solve that integral,
Yeah,
the
actually,
second term?
yeah, it is e over x dx is ex plus c, correct?
Yes.
And when we have a coefficient here, for example, if it's like this, e a x dx, a is a constant,
Mm-hmm.
then we know that the derivative of e ax with respect to x is a e to the power of ax, correct?
That's correct. Mm-hmm.
So when we want to, the integration is actually the reverse of the differentiation. So
That's correct.
when we actually have
That integral on the second line.
yeah, when we want to go from right to the left,
Mm-hmm.
so we want to get rid of the coefficient. So that's why we divide by plus c, but we don't have c here in this example.
Right. Yeah.
So therefore, when we don't have any,
So getting back to that integral, so you have two times integral r divided by 2. So that coefficient a that you wrote down
is
on
one
the
half
side
here
is
actually.
1/2.
Yeah.
Okay, so when you wanted to solve it, you divide the result of the integral by 1/2.
Yes, it's going to be for this example here.
Mm-hmm.
It's like 2 divided by 1/2.
Right.
So it's going to be 4.
Right.
So
Times
yeah,
times e to the power of r
yes,
divided.
yeah, times t to the power of So I just did it in my
Yeah, I know
actually,
what you did. I just wanted to, make it more clear
correct.
for the viewers.
So yeah, that's the explanation for that.
Mm-hmm.
So that's why we have 4 here,
Mm-hmm.
because as we know, if we want to if we actually take derivative of 4, it's going to be 4 divided by 2 er over 2, it's 2e. So
Okay.
this one is this term.
Right. Yeah. That is correct.
So,
okay. Yeah. So this is your final answer for that integral, right?
yes, correct. That's the final answer.
2 times r e to the power of r divided by 2 minus 4 times e to the power of r divided by 2. So
Yes.
just to summarize, so you had the expression inside the integral was a polynomial times the exponential function, and that was a good candidate to use integration by part. And then luckily, you know, the derivative of function e is itself is the same e.
Yes.
So that makes the problem easy. And then so here the polynomial was first degree polynomial, and you use integration by part only once. But generally, if you have like the polynomial was like of a degree of n, then you had to use like n times.
Yeah.
You had to use integration by part n times.
Yes. And yeah,
to,
there is a
to
trick
reduce
for
the power to 0.
Yeah, there is a trick for some problems. If you choose u and v, you know, inappropriately, you actually don't solve the problem. You make it more complicated, you know.
Right, I know what you mean. Like here, if you instead of choosing u equals r, if you choose u equal e to the power of r divided by 2,
example, perhaps,
and then the degree is going to grow instead of reducing.
Yes, yeah. So, I mean, this is very simple, but yeah, sometimes you have more complicated problems and you don't realize, and if you proceed with that selection and you see that it gets more complicated, then you have a key or clue that you chose, you know, the wrong function for u, or the other one, I mean, the other one for dv.
Yeah, hopefully if it's in the exam, hopefully you have time to go back and fix it.
Yes, correct.
All right. Thanks, Amir. Appreciate it.
Sure.
For the viewers, this is all for today. And if you have any question, leave your question in the comment section down below this video. Don't forget to like this video and hit the notification bell, so this way you get notified whenever we upload a new video like this one into our channel. Till next time, bye everyone.
Bye. Thank you.
Thank you.